Hello my friends, how are you all? I, Abhinav SIr, welcome you all on India's largest live learning platform, that is Gradeup. My dear friends, today I am going to start the quick revision of strength of materials, and for the next 3 days, that is today, tomorrow and day after tomorrow, I will be taking important topics from which questions can be asked for GATE 2020. Abhinav SIr, welcome you all. Happy Makar Sankranti to all of you. Okay, yes, good evening Rashid, good evening Yash, good evening Anbak, good evening Ajanke, hi, and hi Shabana. I hope all of you are fine and doing well. So, my dear friends, today my topic is bending stresses. Okay, this is my profile. You all know that I have taken many sessions that are available in YouTube. You can watch them. So this is the mock test that is conducted by our expert team, Gradeup team. So from 15th to 16th, the mock test is available on the app. You can register it now and you can give the mock test and analyze your preparation. Okay, all of you are here. Let's begin the session. Now I am dealing with bending stresses today. My dear Bharat, hello Surya, hello Atik. My dear friends, please like this session and share it on your WhatsApp group or anything, so that more and more people can join us and they get benefited. Okay, hi Bharat, hi Ankit, let's begin the session. So my dear friends, now what is pure bending? In the bending stress topic, many times the word is written as pure bending. My dear friends, suppose this is a beam and I apply a movement here like this and here a movement like this. So the net summation fx. Summation fx is how much? Summation fx, there is no horizontal force in x direction, so summation fx is equal to 0. Similarly, summation fy is equal to 0. There is no force in vertical direction, therefore summation fy is equal to 0. My dear friends, most of you can think that, sir, there is weight in y direction. So my dear friends, I have already told you when I have dealt the first chapter, stress, strain, Poisson ratio, thermal stress in detail, that is also available in YouTube, and you can watch that in playlist 2021 GATE series. That first chapter in which I cover stress, strain, I cover temperature stresses, Poisson ratio in detail. So there I have told you that unless mentioned in SOM, that you will always assume every beam, every column, every bar to be weightless. So unless mentioned, there is no weight. By default in SOM, we assume everything to be weightless. So summation fy is equal to 0. There is no weight. Unless mentioned, there is no weight. So summation fy is also 0. And summation movement, there is a clockwise movement m and anti-clockwise movement m. So summation m is equal to 0. My dear friends, what is shear force? The shear force is, take any section, let us take this section XX. Shear force is summation of force either to the left or to the right. My dear friends, so if I take this XX section, there is no force to the left, there is no force to the right. So shear force at XX section is equal to 0. Similarly, my dear friends, shear force at any section, take any section, from left also, from right also is 0. So shear force at any section is 0. My dear friends, the dm by dx, m is bending moment. So differentiation of bending moment is 0. I can also solve that, derive that, but when we are dealing full SOM in our course. But till then you assume that I have derived it and bending moment slope is 0. My friends, so dm by dx is equal to 0. So this means that any differentiation is 0. This means that If differentiation of anything is 0, then this means that M is constant, that is bending moment is constant. And when bending moment is constant, that is called pure bending. That is called pure bending. So my dear friends, so what is pure bending? When there is no shear force is 0, dm by dx is shear force. When shear force is 0, that is bending moment is constant, then that beam is called in pure bending. Okay, many of you have joined us. Yes, Kritikai, good evening. Yashvi, good evening. Akhil, good evening. Ravi Ranjan is hello. Upal, hi. Okay, the upcoming topics, Kritikai, will be tomorrow I will be dealing with shear stresses distribution, and day after tomorrow I will be dealing with Mohr circle. Okay, so my dear friends, shear force is 0, that means bending moment is constant. Also bending moment is movement either to the left of the section or movement either to the right of the section. Take any section, either to the left is M or right is also M. So bending moment is constant. When bending moment is constant, my dear friends, then that beam is called in pure bending. So we all know that pure bending. If all of you know that what is pure bending, there is no doubt on you, then please write yes sir. Those who are watching in app, write yes sir on app. Those who are watching in YouTube, write on comment box yes sir. If you have understood, then please fast write yes sir on the comment section, whether you are seeing in Gradeup app or you are seeing in YouTube. Okay, Subhas got the concept, Surinder got the concept, Ajinkya got the concept, Kritikai got the concept, Atik got the concept, Ajinkya Ghatol got the concept, very good. Suraj also got, Bharat also got, very good, very good. All of you got the concept. So we know that what is pure bending now. Okay, Pratyashu also got the concept. Let's go further. Now my friends, I am dealing with result of elastic bending. My dear friends, now please very carefully. Haldar got it, very good. Now my dear friends, very carefully see what I am telling you. All concepts that I will be using in this chapter will be covered by me in the coming 5 minutes. So in the coming 5 minutes, I will be dealing with all concepts in this chapter, my dear friends. And see, if you know these concepts, then any question on bending stress you can able to solve. My dear friends, just don't write any comment now. I will let me finish the concepts in 10 minutes. Then after that I will ask you again that have you understood the concepts? Then if you have understood the concepts, then write yes sir. My dear friends, suppose this is a beam and I am applying movement on this beam like that. Okay, so anybody can know that if I am applying movement like that, then resultant shape of the beam will be something like that. The lower fiber has stretched, so it is in tension. Upper fiber has compressed, so it is in compression. So if this length is L, then this length is in more than L, tension, and this length is less than L. This length is more than L, tension, this is less than L, this compression. My dear friends, there will be a layer where still the length is L. That layer is called as neutral axis, where there is no compression, no tension, no compression, no elongation. Length is still L. That is called neutral axis, my dear friends. So if I draw the stress diagram of this beam, then my dear friends, stress diagram will be something like that. Like that. This will be tension, this will be compression. Suppose I write compression with minus and tension with plus, and this is the section, my dear friends, where there is no stress, neutral axis. See, neutral axis, length is still L, no compression, no tension, therefore stress is 0. Since no strain, therefore stress is 0. My dear friends, as we go downward, the length is increasing more, the length is increasing more, and at the bottommost fiber, length has increased most. So as we are decreasing downward from here, as we are decreasing, there is more tension, so tension stress is increasing. Similarly, my friend, as I am going above from here, length is reduced, length is further reduced, and length is reduced most Here the length at the topmost fiber has reduced most. So as we are going above, compression stress increasing. So this is the stress diagram. My dear friends, now listen. We have a formula in this, and that formula is sigma by y is equal to m by I is equal to E by R. Okay? And this formula is called as bending formula, or this is called as flexure formula. Flexure means bending. Flexure is synonym, parayavachi of bending, synonym of bending. So bending formula or flexural formula. My dear friends, now what is this formula? If you understand this formula now, then every concept will be clear. My dear friends, see here. My dear friends, see here. R is the, since this beam is bent, so R, this is a form, this will make a circle. So R is the radius of that circle. R we know, R we all know that. Hello Arbaz. E is the Young's modulus of this beam. E is the Young's modulus of this beam. What is sigma by y and m by I? My dear friends, if I saw the cross section of this beam, the cross section of this beam is something like that. This is B, this is D. Suppose this is a rectangular beam. If I cut this, then there will be the cross section like this, BD, and this will be neutral axis, and this will be, my friends, neutral axis. Neutral axis will always remember. Neutral axis will remember that neutral axis always lies at the centroid. Neutral axis lies at the centroid. So neutral axis will lie at D by 2. D by 2. This total length is D. So where is CG? Where is centroid? It will be at D by 2. My dear friends, M is the moment. M is the moment at that section. I is the moment of inertia about this axis, neutral axis. I is equal to I about neutral axis, and this is equal to BD cube by 12. Sigma is the, suppose I am enlarging this, my dear friends. This is this, and y is the distance from neutral axis, and sigma is the stress. Sigma is the stress at y distance above or below the neutral axis. I am repeating, sigma is the stress at y distance above or y distance below the neutral axis. My dear friends, sigma is the stress that is y distance above neutral axis, and my dear friends, this sigma is bending stress. I have not applied force P. Force is equal to P by A. I have not applied P force on this beam. I have not applied P force on this beam. This stress is due to bending. I have not applied P force. This stress is due to bending. This stress is due to bending. Bending due to M. So this is called bending stress. Bending stress. My dear friends, I again explaining this formula. This is Young's modulus. Young's modulus of the beam. R is the radius. This beam is bent, and there will be it will bend in a form of circle. So R is the radius. M is the moment that is applied on the beam. I is the moment of inertia about neutral axis. Suppose rectangular section, then I will be BD cube by 12. Sigma is the stress. Where stress? Where stress? This is bending stress. Where? At y distance above neutral axis. So whatever y you will write, you will get sigma at that distance from neutral axis. Okay. Now see, my dear friends. My dear friends, see. This sigma is the bending stress at y distance above. Now my friends, from here I can write that M is equal to sigma into I by y, or I can write as, my friends, sigma is equal to M by I into y, or anything I can write. Sigma is this also, and I can write this also. Now my friends, M is equal to sigma. If I consider this, M is equal to sigma by I into y, then MOR is moment of resistance. Moment of, hello Ankush, moment of resistance is the maximum movement that beam can sustain without failure. MOR is movement. MOR is movement only. It is M only. Maximum movement that beam can sustain without the failure. My dear friends, MOR is M, and it is when maximum movement it is having, then sigma is sigma max, and sigma max will occur when sigma, this is the maximum sigma max or below, both are symmetrical because this is D by 2. So sigma max will occur at y max into I. So I by Y max is Z. M sigma max into Z. Z is section modulus. So MORS sigma max into Z. And my dear friends, Z for rectangular section, I by Y max, this I by Y max is Z. Z for rectangular section is C. I is how much for rectangular section? BD cube by 12. I for rectangular section is BD cube by 12, and Y max is maximum distance from neutral axis. Maximum distance is D by 2. So this is divided by I, D by 2. So Z is how much? BD square by 6. Z is how much? BD square by 6. My dear friends, so MOR for rectangular section is sigma max into BD square by 6. I am again explaining now, my dear friends. I am again explaining this very carefully. I am again explaining. Most of you have understood till now also, but let me explain it again. This is very important concept. Therefore, I am explaining this concept to you again. My friend, just after that only write something on the comment box. I will ask you, then only write something on comment box. Just see, my dear friends. Don't worry. Just see. See, my dear friends. This is the movement that I am applying on the beam. Then due to this movement, beam will be something like this. Okay. So here the member is increased, therefore tension. Here it is decreased length, therefore compression. Suppose this length is L, therefore there might be some axial fiber like this whose length is still L. So here the length is increased, therefore tension. Above the length is decreased, therefore compression. Here L length, earlier also L, now also L. This is called neutral axis. At neutral axis there is no strain. Strain is 0, therefore stress is 0. My dear friends, if this is rectangular section, then let me cut this like that. We will have rectangular section like B and D. Where is neutral axis? Always remember, neutral axis at neutral axis at centroid, at center of mass. So here neutral axis will be like this at D by 2. So symmetrical. Since above there will be compression and below there will be tension. Okay, stresses as we are going further decreasing, as we are going downwards from neutral axis, stresses are increased because here elongation is most, therefore stress is most. As we are going above, compression is increasing and most compression is at the top, therefore there is maximum. So by this is also D by 2 and this is also D by 2. So both will be same, sigma, it is maximum, sigma max. My dear friends, we have bending or flexure formula. Sigma by Y is equal to M by I is equal to E by R. This is called bending formula or flexure formula. E is Young's modulus of the beam. R is the will form an arc of a circle. R is the radius of that. M is the movement. I is the you can cut anywhere, Haldar, you can cut anywhere. Wherever you cut, you have to take M of that section, movement of that section. My dear friends, I is the moment of inertia about neutral axis. For rectangular, I is how much? BD cube by 12. I is the moment of inertia about neutral axis. Sigma is the stress. It is bending stress. This sigma is not force by area. This sigma is not force by area. Force is not acting. These stresses are coming due to movement. Therefore, they are called as bending stresses. And this sigma is of where Y is the distance of neutral axis. Suppose bending stress is like this. So if I put Y as something like this, then sigma will get off here. If Y I put as D by 2, Y is the distance from neutral axis. If Y I put at D by 2, then Y got sigma max. Sigma max. From here, M is equal to sigma into I above Y. I by Y is Z. So moment of resistance, M moment of resistance, that is maximum moment that beam can have without failure. This is sigma. I by Y is Z. So Z for rectangular section is I is how much? BD cube by 12. And moment of resistance means maximum moment. At that time sigma will be sigma max. And sigma max is occurring where? At Y is equal to D by 2. So Z is equal to I by Y. So I is BD cube by 12. And Y is how much? Moment of resistance is maximum moment that beam can resist. So what is Z? Z is I by Y. Y is how much? D by 2. So divided by d by 2 is equal to bd square by 6. So for rectangular, it is bd square by 6. Okay. So this is moment of resistance, that is sigma y into z. This sigma into bd square by 6. My dear friends, Gurpal is asking what is R? This beam bends into form of a circle, and circles will having some radius. That is called radius. This again telling I am again telling this beam will bend in a form of circle, and that circle is having some radius. This circle having some radius, that is called R. Okay, my friends. Okay, I will ask you, then only write some comment. I will ask you, then only write some comment. So MOR is sigma into Z. My dear friends, this is called moment of resistance, that is maximum that can attain. Now once more, I am telling the concept in Hindi yaar. I am telling the concept in Hindi. My dear friends, see here now. See here. Just wait for 5 minutes. Just wait for 5 minutes. Then I will ask you to write the comments. Then I will ask you to write the comments. Just wait for 5 more minutes, my dear friends. Now I am telling in Hindi. Just wait for 5 minutes. देखो भाई, ये बीम पे मूवमेंट लगाया तो ये बीम ऐसे मुड़ गई तो ये किसी सर्कल का पार्ट होगी. सर्कल का पार्ट होगी तो उस सर्कल के रेडियस को कहते हैं आर. मेरे भाई जैसे जैसे न्यूट्रल एक्सिस से ऊपर जाते जा रहे हैं, कंप्रेशन बढ़ती जा रही है और सबसे ऊपर सबसे ज्यादा लेंथ श्रिंक हुई है, सबसे ज्यादा कंप्रेशन. ऐसे ही जैसे न्यूट्रल एक्सिस से नीचे जाते जा रहे हैं, लेंथ बढ़ती जा रही है और सबसे नीचे लेंथ सबसे ज्यादा बढ़ गई, सबसे ज्यादा टेंशन. तो जो बेंडिंग स्ट्रेस होंगे वो होंगे ऐसे, यहाँ कंप्रेशन, यहाँ टेंशन. और न्यूट्रल एक्सिस क्या होती है? सेंट्रॉइड पे. तो सेंट्रॉइड कहाँ होगा? डी अगर लेंथ है तो सेंट्रॉइड कहाँ होगा? यहाँ से d by 2, यहाँ से d by 2. ओके मेरे भाई, m क्या है? मूवमेंट ऑफ मूवमेंट. तो m मूवमेंट क्या हो जाएगा? सिग्मा बाय y इंटू आई. मेरे भाई MOR होता है मूवमेंट रेजिस्टेंस कि कितना मैक्सिमम हो सकता है. ओके अंकित जैन, व्हाट इज अंकित आस्किंग व्हाट इज R? अंकित, जब ये बीम बेंड हो जाएगी ना, दिस बीम इज अ पार्ट ऑफ अ सर्कल एंड दैट इमेजिनरी सर्कल इज दिस. दैट सर्कल्स रेडियस इज R. This beam will bend in a form of a circle. This is a part of a circle. That circle has radius R. My dear friends, let's movement और resistance की maximum कितना beam movement ले सकती है. तो जब maximum movement लेगी तो समय सिग्मा क्या होगा? सिग्मा मैक्स ओके इंटू आई. और सिग्मा मैक्स कब होता है? मैक्सिमम दूरी पे वाई मैक्स. चाहे ऊपर की बात करो चाहे नीचे की बात करो, सिग्मा मैक्स कब होता है? मैक्सिमम. ये वाई वही रखना है जहां पे सिग्मा रख रहे हो आप. तो सिग्मा, अगर सिग्मा मैक्स रख रहे हो तो सिग्मा मैक्स कहां पे आता है? वाई मैक्स पे. तो रेक्टेंगुलर के लिए आई BD क्यूब बाय 12 होता है और इसको जेड भी कहते हैं मेरे भाई, सेक्शन मॉडुलस. तो MOR इज इक्वल टू सिग्मा मैक्स इंटू जेड. तो मेरे भाई सिग्मा मैक्स जेड हो जाएगा रेक्टेंगुलर के लिए, ये BD क्यूब बाय 12 और ये d by 2, तो ये BD स्क्वायर बाय 6 हो जाएगा. मेरे भाई देखो इधर, मूवमेंट ऑफ रेजिस्टेंस को हम कह सकते हैं सिग्मा मैक्स इंटू जेड बी. तो मेरे भाई मूवमेंट रेजिस्टेंस इक्वल टू सिग्मा मैक्स इंटू जेड. यहां से मूवमेंट ऑफ रेजिस्टेंस निकालेंगे. दोज हु हैव अंडरस्टूड प्लीज राइट यस सर. Those who are watching in Gradeup app, write yes sir there. Those who are watching in YouTube, write yes sir there. Haldar has understood. Abhodna Mishram understood. Suraj understood. Gurpal understood. Yes, understood. Shashank, just rewind it, then again see, please. My humble request. Sumania has understood. Shabana understood. Surinder understood. Bhatt understood. Sakshi understood. Ankit understood. Okay, all of you have understood. Okay, now my dear friends, Krishna has understood. Okay, Kritika is asking doubt that how to calculate radius if curvature is given. Kritika, radius is 1 by curvature. It is reciprocal. If radius is 3, curvature is 1 by 3. If radius is 4, curvature is 1 by 4. Do this question, all of you. Vivek, please, my humble request, just rewind this, then again, please see it. I have explained 3 times, you will get to know then. Nitin, MOR is sigma into Z. Z depends on shape. BD, Z is BD square by 6. That depends on shape. And MOR depends on material and shape both. MOR is sigma Y into sigma max into Z. So sigma max, maximum stress, how much it can take depends on material. And Z only depends on shape. Just do this question, please. Please, all of you like the session also. Please like the session and share it with your friends. See, let me explain you. You only will solve it. Let me explain you. This is a wooden circular log. And how many rectangles it can have? You can cut rectangle like this. Just let me explain the problem, then you will solve it. Let me explain it. Rectangle can be like this. Rectangle in this can be like this. My dear friends, rectangle in this can be like this. So there are infinite rectangles, okay? There are infinite rectangles. So let us take a rectangle. Let us take a rectangle like this. Suppose this is B, this is D. So moment of resistance MOR is how much? MOR is how much? Sigma max into Z. Now my friends, this depends on material. Sigma max depends on material. Every other material has different sigma maximum stress it can take. And Z depends on shape. See, Z for rectangular is how much? BD square by 6. So B into D, width into depth, it depends on shape. So MOR is sigma max into Z. So we can derive infinite rectangles. Out of those, I have to find out for which the moment of resistance is maximum. So for all these, either it may be black rectangle or blue rectangle or red rectangle, sigma max is same. Sigma max is same. So moment of resistance is maximum when? When Z is maximum. Moment of resistance is maximum when Z is maximum. Why? Why? Because this will not be any effect. Sigma max will not produce any effect. Why? Because all the rectangles, either blue, black or red, will all be of wood. All will be of wood only. Therefore sigma max of wood will be constant. So sigma max will not cause anything. So all are due to all are wood. Therefore for that rectangle will be having maximum moment of resistance, for which Z will be maximum. Moment of resistance maximum when Z is maximum. Sigma max is same. Okay, very good, Nitin. Maruti. No, Maruti, just please check it. Okay, see, let me solve this. The diameter is how much? D. Okay, so Z is how much? Z is BD square by 6. So from here I can say that B square plus D square is equal to capital D square, Pythagoras theorem. So here I can write Z is equal to B. D square I can write as D square, I can write as, see from here, D square I can write as D square minus B square. D square minus B square by 6. So for maximum, dz by dB is equal to 0. If you put dz by dB is equal to 0, I am not going in calculation part. My aim is to give you concepts. So dz by dB is equal to 0. If you differentiate it, let me do dz by dB. Differentiate it, 1 by 6 is common. So here it will be d square minus, it will be b cube. So how much? 3b square is equal to 0. From here I will got b is equal to d by root 3. So b is equal to d by root 3. Put b is equal to d by root 3 here. B is equal to d by root 3 here. So this is d square by 3 plus d square is equal to d square. So from here you will got the answer as root 2 by 3 into d. So d is equal to root 2 by 3 into D. I am writing here D is equal to root 2 by root 3 into D, like that. Okay, very good Nitin, excellent. Kritika asking why dz by db is equal to 0. Kritika, see, we have to find out the maximum moment of resistance, maximum. So moment of resistance is how much I have derived earlier, sigma max into z. So moment of resistance is sigma max into z. So for all these rectangles, either blue, either black, either red, sigma max will be same because all are of wood only. So sigma max will be same. So this is not changing because wood only. So moment of resistance is maximum when z is maximum. So z is this much. Therefore for maximum, finding out the maximum variable dz by db is equal to 0. Like we have to find out maximum value of y in our 12th class. What we do, dy by dx is equal to 0. Same like that. Okay, I hope all of you have understood. Let's move further, my friends. Now solve this. Where will be the neutral axis? Neutral axis is always at the centroid. Total length is 150. Therefore, this will be neutral axis. And stress diagram is how? Like this. At neutral axis, stress is how much? 0. So stress diagram is this. We have to find out Maruti, moment resistance depends on material and shape both. I cannot just comment on material. Moment of resistance is sigma max into z. So sigma max is also a factor which depends on material, and z is also a factor which depends on shape. Generally, I section has maximum z. Now, force we have to find out on this region, my dear friends. Force. So stress is equal to force by area. We all know that. So force is how much? Stress into area. Stress into area. So let us suppose stress here is how much? Suppose sigma. Stress here is sigma. At how much distance below? At 25. So we know that sigma by y is equal to m by I. I want to find out sigma where? At 25. Y is the distance from neutral axis. This is 25. M is how much? 16 kilonewton meter. So 16 into 10 ki power 6. If I want to calculate in Newton per mm, Newton mm. I is how much? B d cube. I is moment of inertia about neutral axis. So B d cube by 12. B is how much? 100 into d cube is how much? 150 cube by 12. So from here sigma you will got as 14.22. Okay, now force is stress into area. So in area is how much? See, I want to calculate force in this region. Area is how much? Area is 25 into 50. 25 into 50, and stress. Stress here is 0. Stress here is 0. Stress here is 0. And stress here is 14.22. So since it is varying linear, here stress is 0, here stress is 14.22. Since it is varying linear, so average stress I can write as 0 plus 14.22 by 2. So from this, if you calculate, the answer will be 8.9 kilonewton. I hope you understood. I hope you understood. Please write on comment box. I want to calculate force on this region. So area is this much, and stress at below is 14.22, at above is 0. So average is how much? 0 plus 14.22 by 2. Now do this question. Amrito, strain diagram is also linear, stress diagram is also linear. See Amrito, stress by strain is equal to Young's modulus. Stress is equal to strain into Young's modulus. If strain diagram is linear and to a linear function I multiply a constant, then that is also a linear function. Strain diagram is linear and I multiply a constant with a linear function, then that is also a linear. Now calculate this fast, my dear friends. Okay, very good, Vivek. Hello, Pranav. Hello, Bharat. Bharat, very good. प्लीज लाइक द सेशन भाई, लाइक करते चलना, लाइक करते चलना. Very good, Maruti. See, at XX section I want to draw. So let us draw XX section. It is something like that. How much force is coming? P. And my dear friends, please listen very carefully now. Please, civil gate question. Mohit, it is civil gate question only. Don't worry. Please listen very carefully now. This P is acting here. Okay. Now, if I calculate neutral axis of this is how much? D by 2. So, if I calculate neutral axis, so neutral axis at centroid and this length is D by 2. So, where is neutral axis? It is at D by 4. This is D by 4, this is D by 4. This is D by 4, this is D by 4. Please listen all of you very carefully. Please. This is a very typical question. This is D by 2. So, neutral axis is at centroid. So, D by 4, D by 4. So, if I calculate this P, then there is a movement also about this. This distance is D by 4. So, this movement is how much? P into D by 4. This is movement also. Movement also, bro. See, this bottle, if I apply a P force here now, then there will be a movement also. Movement also. I am again saying, if I apply a P force in this bottle now, then this bottle will rotate also, yaar. This bottle will rotate also. Okay. So, how much is the movement? How much is the movement? Movement about this axis, neutral axis is P into distance. Distance is how much? D by 4. So, this is movement, this is force. So, it will be acting. See, if I apply this P force now, then force is P. No worry, force is P. And movement also P into D by 4. Movement also P into D by 4. So, both is acting. So, what is stress? Stress is, one is force by area. Force is by area. One stress is force by area. Not bending stress. Not bending stress. Not bending stress. Force by area. Area is how much? B into D by 4. Plus one stress is bending stress. Bending stress is how much? We already derived. I told you this formula, sigma by y is equal to m by I. So sigma is how much? M into I by y. So sigma is equal to 4p by bd plus m is how much? M is how much? PD by 4 into I is how much? I of this section, yaar. BDQ by I is how much of this section? BDQ by 12. D is how much? D is how much? This D is how much? D by 2. So D by 2 ka cube. BD cube by 12. This is I. This is M. And Y is how much? My friends, Y is how much? From neutral axis, the top distance is how much? From neutral, Y is the distance from neutral axis. From top distance how much? D by 4. I am not going in calculation. I am not going in calculation, and the answer will be, if you solve this, 8p by bd. That is option A. Let me repeat once more. Let me repeat once more. Let me repeat once more. My dear friends, see, I want to calculate the stress at XX section. Okay, I want to calculate stress at XX section. Okay, so if I draw this XX section, there will be P, and my friend neutral axis will be at centroid. So this total is D by 2. Centroid will be how much? D by 4. D by 4, and P will cause movement also. How much movement? P into distance. So distance about neutral axis how much? D by 4. So P into D by 4. This is movement also. So stress is force by area. P area is how much? B into D by 4. B into D by 2. Oh sorry. B into D by 2. B into D by 2. Okay. So area is how much? P into D by 2. Okay, it will be 2, not 4, not 4. P into D by 2. Plus area is force by, this is not bending stress, this is force, generally simple, force by area. So area here is how much? B into D by 2. Plus bending stress is how much? M by I into Y. So 2P by BD plus M is how much? PD by 4, movement, into M by I into Y. Sigma by Y is equal to M by I. Sigma is equal to M by I into Y. Divide by I. I is how much? BD cube by 12. D is how much of this? D by 2. So D by 2 power cube into 12. into y. Y is distance from neutral axis of the top. Is how much? D by 4. If you calculate this, 8p by bd. Have you understood? Have you understood now? Earlier the question, there was slight calculation mistake. Have you understood? Please write quickly. Have you understood? कहाँ चले गए सब यार? Just who are seeing in app and YouTube, please write yes sir if you have understood. Gaurav has understood. Aman has understood. Gaurav has understood. Maruti has understood. Muhammad Mustaqin has understood. Shashank has understood. Pranav has understood the concept correctly. Shivani Sharma has got the concept. Jitendra has got the concept. Please, all of you who have understood the concept, just hit the like button. Deepak has understood. Manoj has understood. Shabana is asking no once again, please. Kishan understood. Kishan Roniar, okay, yeah, hello Kishan. Shabana, just rewind once more. You will get to know, don't worry. After the session, just rewind. Shailesh has understood. Okay. Now this question. A beam is given. Actually, beam is not given there. I will draw this. So, beam is given like this. This is aluminium and this is steel. This is 30 mm and this is 40 mm and this is 80 mm, and we have to find neutral axis from top. Okay, very good, all of you have understood. Good, Shabana. Young's modulus is also given. Okay, now see, whenever this is the question now, whenever this is asked in such kind of questions where there are two different metals, then see, all of that we have derived now. Actually, Jatin, when we start the course now, that is available in app also, you can take the free mock trial. There our team will give the PDF, not for YouTube sessions. Okay, see Ajankya now. Before you solve it, let me tell you the concept. My dear friend, this is the problem, this is the figure, and I have to find out the neutral axis. My friends, whatever I have told you the formula na, sigma by y is equal to m by I is equal to E by R, that formula is applicable for pure bending and for homogeneous section. Homogeneous section means the whole beam is of single material. I am repeating, Sumit, don't worry. The neutral axis is as at centroid, and that is applicable for homogeneous beam. So we have to convert this beam into homogeneous beam. Homogeneous means everything should be of aluminium or everything should be of steel. I am again repeating, everything should be of aluminium or everything of steel. Now if I have to convert this everything of aluminium now, then see what I have to do. Aluminium, converting this aluminium to aluminium, this is 30, it will be 30, it will be 40, no worry. But here when I converting steel into aluminium now, then I have to multiply it by m times. And m is how much? Ratio of Young's modulus, 200 by 75. So this depth is not changed, depth will be again 80, but this will be 200 by 75, m times I have to multiply for getting the now width, m times of sigma, m times of now initially it was 30 into 30, 15 to the 30, 15 5 to 75, it will be how much? You will got as 80, like this. Okay, my friends, I am again telling you the concept. My friends, whenever you have to find out the neutral axis now, then You have to find neutral axis for homogeneous beam. For homogeneous beam, either it should be all of steel or it should all be of aluminum. Let I am making of aluminum. Then this aluminum 13 to 40 will remain as 13 to 40. I am converting into aluminum. Okay. So this is aluminum. Okay. Now I have to convert steel into aluminum. Then for converting now, depth is same. First point, remember, depth is same. It is 80 also, it is 80. Width is multiplied by m times. M is the ratio of Young's modulus. So 200 by 75 into 30. 200 by 75 m times into 30. It is coming how much? 80. Now this is of aluminum. Don't worry Prakash, I will repeat. सुनो देखो भाई, जब भी मेरे को न्यूट्रल एक्सिस निकालना है ना, तो न्यूट्रल एक्सिस लाई कहाँ करती है? सेंट्रॉइड पे. न्यूट्रल एक्सिस लाई कहाँ करती है? सेंट्रॉइड पे. लेकिन सेंट्रॉइड निकालने से पहले तुम्हें सबको या तो एल्यूमिनियम में कन्वर्ट करना पड़ेगा या सबको स्टील में कन्वर्ट करना पड़ेगा. सबको जब मैं मानता हूं एल्यूमिनियम में कन्वर्ट करने का, तो एल्यूमिनियम को एल्यूमिनियम में कन्वर्ट करने के लिए तो सेम डायमेंशन, लेकिन स्टील को एल्यूमिनियम में कन्वर्ट करने के लिए मैं एम डेप्थ में चेंज नहीं करूंगा, लेकिन विड्थ मल्टीप्लाई कर दूंगा एम टाइम्स. क्यों एम टाइम्स से क्यों मल्टीप्लाई कर दिया? देखो एल्यूमिनियम का यंग्स मॉडुलस इतना है और स्टील का इतना है, तो ज्यादा शक्तिशाली कौन है? शक्तिशाली कौन है? जिसका यंग्स मॉडुलस ज्यादा है. स्टील ज्यादा शक्तिशाली है. तो स्टील ज्यादा शक्तिशाली है ना, तो अगर मेरे को स्टील के बदले एल्यूमिनियम लगाना है, एल्यूमिनियम कमजोर है, तो मेरे को ज्यादा एल्यूमिनियम लगाना पड़ेगा. क्योंकि स्टील मजबूत है, एल्यूमिनियम कमजोर है, तो ज्यादा लगाना पड़ेगा, तो मल्टीप्लाई करूंगा. अब सारा एल्यूमिनियम से हो गया. डेप्थ कभी चेंज नहीं करना. अब नाउ आई हैव टू कैलकुलेट सेंट्रॉइड फ्रॉम टॉप. सो रिमेंबर दिस फॉर्मूला दैट वी लर्न इन स्कूल फॉर कैलकुलेटिंग द सेंट्रॉइड. ओके, नाउ y bar is equal to a1. A1 is how much? 13 to 40. Center of mass from top. Center of mass from top is how much? 20. Plus A2 is how much? 80 into 80. And center of mass from top is how much? This 40, this 40. 80 upon A1 plus A2. 30 into 40 plus 80 into 80. It will come as something around 71.70. It will come something around 70.5. You can calculate. I am not wasting time. Okay, now my dear friends, from top Aman. Okay, from top I have to calculate. Okay, so now see, आप ना इसको स्टील में भी कन्वर्ट कर सकते हो मेरे भाई. आंसर निकाल के देखना होमवर्क में, स्टील में भी कन्वर्ट कर सकते थे. देखो ध्यान से देखना भाई, स्टील में भी कन्वर्ट कर सकते थे. देखो मैं स्टील में कन्वर्ट करता हूं, तो स्टील के बदले स्टील तो उतना ही रहेगा. डेप्थ कभी चेंज नहीं करनी भाई मेरे भाई, डेप्थ कभी चेंज नहीं करनी है. स्टील के बदले स्टील तो उतने का उतना ही रहेगा. 80 into 80. स्टील तो उतना ही रहेगा. 80 into 80. स्टील उतना ही रहेगा. स्टील के बदले स्टील. अब ना स्टील इज मोर स्ट्रॉन्ग एंड एल्यूमिनियम इज वीक. So if I have to convert this into steel, then steel is stronger. Then I have to apply little steel. Depth will not change. Depth will be 40. Depth will not change. Now I have to convert this steel. Steel is stronger. Therefore less steel is required. So I have not to multiply 30 by m. I have to divide it by m. And m divided by m. Divided by, not multiply. It will be divided by m. M is how much this? Anything value you will get, then the same formula you get the same answer. अरे आया कि नहीं आया? ये right yes sir if you know the concept. If you understood the concept, right yes sir. Hi Mani, just right. No Gaurav. In our course depth will be constant. We multiply generally width. Kishan got. Gaurav, in our course we keep depth constant. Width we change. Shivani got the concept. Gaurav got the concept. Prakash got the concept. Karthike got the concept. अरे आ रहा है कि नहीं आ रहा? जिसको आ गया लाइक कर दो भाई, लाइक. See, Shashank is asked out. Y2 is 80. Since Y2 is center of mass of this, so this center of mass is at, this total is 80. So center of mass is at 40. So from top I am calculating. So from top this point is at how much distance? 40 plus 40. So Y2 bar is 80. Y2 bar is distance from top of centroid of this. 40 plus 40 is 80. You all got the concept. Okay. Okay, yes, Kirtigai. Good, good, Abbas, good. Abbas was my offline student, very good. Okay, so you all know that you can install Gradeup app, write Abhinav Negi on app, and you can follow me. You can follow me there. Our free trial is available from 20th January. I am starting the first subject survey. That subject will be completely taken by me in considering GATE, engineering services and other competition exams. Still these days also we are having some classes for you from 20th January. First subject survey will be launched. These days also we are having some classes for you in preview period. You can take the free trial just on your Android phone, install the Gradeup app and take the free trial. So this is the green card. By taking green card you can access more than 130 plus mock test. Prep smart, my friend, score better, and my dear friends, just like the session and follow me and also comment on it if you like it. So tomorrow I will be meeting you at 5:30 p.m. for the next chapter, shear stresses. Okay, my dear friends, thank you.